We have one speaker in this session, a very interesting talk. It will be by Marco Zaccaria. Marco finished his PhD at the University of Cambridge on bi-tempering of glass, and he's now already for several years at the R&D department of IGC, where he studies multiple applications of architectural glass. And today he will share his vision on the end-of-life scenarios of glass elements. So Marco, the floor is yours.
Thank you, Christian. Actually, this talk is from waste via recycle to reuse, and the focus of this work is partly some of activities that I've done at the R&D, but mainly the development of a machine done at EGLA. And so, strictly speaking, I'm somehow replacing the main speaker. I'll try to do my best, but surely the topic is interesting for all those who really want to see something about circularity. So overall, I will tell you why we are doing this, and then what it is that we are doing it, and then some results which are not related to the machine, are related to the glass that comes out of this machine, and then what will come next. Did I went too fast? Okay, no, not too fast. Okay, so why we are doing motivation? I think these numbers has been recurrent in many presentations so far, and the problem is there. We got a float plant output, a certain amount, and then when you have this glass that is produced, 50% of this normally gets into IGU. So this tells us that IGU is the most widespread architectural product and glass product. So then figures vary from country to country, but let's say there is pretty much 3% of internal carlet. These figures are from 2018, if I'm right. I'm sure that these figures are increasing for all the company, and this is clearly good, and we hope that these numbers will keep on increasing. But then, once these IGU go into their building and they get used, they get to their end of life. So what options we have? Landfill so far was one of the main options, and the other option is what we call the recycler option, so that the glass is collected by a waste collector, this is crushed, and so there are some applications which are notably downcycling into other glass application or other material. The reason why this glass does not go back into the float plant is because of contaminants. So that's really the problem there. So that's the problem we were facing. And also, the amount of post-consumer glass that goes back into the float plant is also in very low numbers. So can we maybe do something in there? So far, when you have this IGU, they get there are different types also, so I'm talking about the end of life, but there is also a good quantity of IGU, which are normally failure in production. And then there are instead, for example, when you have renovation works, that these windows are collected, and then they get binned, they get sorted in some ways which are not the best. So we got something out of production, something which is returned, and in the end, it's always the same. As you can see, the picture is even bigger than the glass. So what I'm saying here is also an invite to people who are somehow marginally to the glass, and they also touch the other parts of the facade, that there is potential even beyond there. What do we do with glass, but what do we do with the frames? So on the frame is not what we are working on, but surely there is room there. And the question is this a value or is a source? If someone can find a value there, the value might be big because we saw the numbers are big. So in order to face this problem, what was conceived? It was conceived, first of all, let's see what the concept is. That let's try to valorize this scrap. The first thing that happens is that the glass gets back into the float plant. This can happen, okay? But float plants are not very widespread on the territory. So for example, if you take EPDs, they have to make assumptions, and many times the assumption of the distance from the building to the float plant is in the range of 1,000 kilometers. So that means that if we are using the glass for recycling and we consider only the transport, very likely this glass will travel a lot of distance. But yet, it's a good thing to do, and we should encourage it, and we should do it. And the method is what I mentioned before, so that the glass is collected, is crushed, then is sorted, and then gets remelted, And then you can do new products, but by remelting. But what? I was back. Sorry, I was looking on the wrong part of the screen. I hope I didn't disturb this. But then what happens if we actually do another thing? That is, let's try to upcycle this glass, which means instead of remelting the glass, we reuse it. Now, there is a little bit of dictionary clarification here, and my clarification comes from the Declaration Product Standard, where there are defined some terms like reuse, remanufacturing, recycling. I heard some confusion even in the talks that I've been to. So if you think at the IGU level, the reuse, it means you take it from a building and you move it to another building without doing nothing. That's how you reuse your IGU. But if instead you take this double glazing and you break it into parts, and then you make something else out of it, which what we are advocating for here, that's remanufacturing, okay? So strictly speaking, I should say remanufacturing. Reuse is much easier to use as a term, so forgive me here if I mix the two, but when I mean reuse, I do not advocate to reuse the IGUs because we all know that they have a certain lifespan, so disassembling from a building and bringing it somewhere else could just be a waste of energy because it will fail eventually, okay? So if we can conceive that we can upcycle this glass, so separate the single panel of an IGU to make something else, something new out of it, remanufacture out of it, how the things can go. We partnered EGLA and AGC together, where EGLA is a machine manufacturer, and AGC is a float glass manufacturer and glass processors. And so the idea is that we will collect post-consumer glass directly from the building, whether these are facade or interior or you name it, everything that has a value. And then it will go through a machine which is conceived, and this machine has the role of slicing the two panels of the glass independently. And so in this way, you will have the two panels that are separated. What can you do with that? This could become a cullet of a quality that the recyclers cannot match. And so that will be a high added value already for some activities that all companies are trying to implement right now. But also, we can think of remanufacturing with this. And so that would be actually very practical to do other stuff. What can we do? We can do IGUs, we can do partitions, we can do furnitures, and clearly in order to redo something, we have to qualify what we are doing. For those who did not attend on the talk on the qualification of the glass for reuse, I inform you that there is a journal paper which will be soon published on glass structures and engineering. It already went to the review process by Angelica Rota and me and Professor Fiorito. And there we explain what we did for clear float glass and how to reuse it and whether this is safe and what we foresee for that. And that's why here we list some applications, because if the glass is good enough, probably the best thing we could do is do an IGU. But if the glass is not good enough, there are other applications where the mechanical strength is not that important, and yet it's not downcycling because glass is still used for furniture and things like that. So, it's quite interesting to see what we can do. Overall, in terms of terminology, given that I think it's also important, I found out this new name, which I call it remanucycling. And the thing is that when you dismantle your glass from the building, you don't know what to do up front. So we started to talk with someone who is interested in do something out of this building, or out of this glass, and they say, I want you to reuse it, or I want you to recycle. And I don't have the magic ball, so I don't know what I can do up front. But all I know is what's right to do. So we will take the glass, and then following the waste hierarchy triangle, we choose what to do according to the glass type and according to the quality that this glass specifically has. So this new term, which I hope will widespread, is remanucycling, because we need to be specific. So now, in the detail, this small element of the machine that is there, let's magnify it a little bit. And the way it's conceived is basically similar to an IGU line, yeah? Like you have this stands, and the glass gets loaded on the left-hand side, then it passes through the cutting process, and so out of IGU, you got two glass panes. In the bigger picture, we should also know that the IGU is not only glass, there's also spacer, there's also desiccant, there are sealants, and if we do remanufacturing, we are not doing remanufacturing on glass only, we are doing remanufacturing on all the components. The amount of work to do is huge, so far, represent a glass company, I focus on glass. So here is also an invite to all those who are interested into this remanufacturing process. If there is some workforce who want to remanufacture also the other components, clearly there is a good opportunity there. And so in the end, we have these two panels. We have the frame, we have the desiccant, and potentially we could also do some recycling. So far you only saw drawings, and then you say, okay, nice concept, nice stuff, nice drawings, then what? No, it's not a what like that. The what is real. This machine is a prototype for the moment and is in one of AGC plants. As I speak, there are technicians who are operating, we are fine-tuning, and we clearly want to go ahead as fast as possible into this process. But for those who like basketball, I like to mention Greg Popovich, we cannot skip steps. So we really need to understand what we have to do, and we have to do it properly, because this is really important. We have to do this in the best way. And so I'm not the representative of Hegla, but there is a stand of Hegla here, so I really invite you, if you want to know more about the machine, to get in contact with Dr. Ostendarp, who is also here with us. And so he can tell you more detail about the machine and when we are standing there. So start to think about this machine, what can we do? Well, many things, sky's the limit, hopefully. So this machine can do repair. What is repair? When you have a defective IGU, instead of having to redo it from scratch, so recut the glass, grind the glass, put the sealant and so on, you could simply reopen it and try to reuse those same panels to do that. Then you can recycle, of course, we mentioned that already, and then reuse. Here we say future because I'm an R&D guy, so I'm not here for a sales pitch. I'm telling you again the lab mouse activity that I do from time to time, on a daily basis, and luckily some of these lab activities are not in the lab, but are in a factory where this machine is. So in terms of the repair, that is, you got a defect in there, instead of doing all the instead of redoing this IGU from the order point of view, you will just cut it. This not only will save material, but for example, from a time point of view, it will help to meet the timing of the customers. So these are things that are to be taken into account for the value that this machine can do for that. Then clearly, it can be used to get glass for recycle. We made a lot. Okay, there are some facts about return of investment. But probably the best person to talk about these facts are with Mr. Ostendarp, so I will not spend too much time on that. And then on the reuse. And yeah, that's not only the added value of what is on the glass, but clearly you can imagine I do not have figures of EPD of a remanufactured glass, but I let you assess by your own rationality that if you are not burning, the advantage is going to be there and is going to be big. So, line concepts. What we have in the factory, it's only a prototype, so only one stillage, let's say, where we only maneuver the glass, and we have still a lot of manual operation. We are learning as we do. But there are different concepts of the line, where, for example, you might have it only to prepare glass for recycling, so you separate the glass, and then you can have a fine crusher at the end of it. And in that case, we expect that the quality of the cullet will be of a higher quality than that it comes from the recycler, although I must say test has not been done yet, so I do not have value for that. But then there could also be an automated line, and the automated line might have something more than simply the separation of the glasses, could have some cleaning of the sealant, could have the recuperation of the spacer, the desiccant, and what have you. And then there will be the fully integrated line, where this line could be integrated into a plant. The way I imagine, to be honest, is that in a process plant, this could be back-to-back with a manufacturing IGU line. So in one direction you disassemble, then you turn the corner and this manufactured on the other side. But okay, this is a little bit about Fanta glass there. And then there are some numbers there about efficiency. That's fine. The thing is, the faster the machine is, the better it will work, but it's not only about speed, it's also about quality. So we will have to fine-tune the compromise into the speed of that, and that's why we go regularly in there. And so, again, this is a collaboration, EGLA and AGC. That's the part of EGLA. What's the part of AGC there? We wanted to evaluate what happens with the glass that comes out of the machine. And one of the questions that many people ask is like, okay, but this is post-consumer glass. What about warranty? You know, what's going on? And so we wanted to focus primarily on the sealant because that's what matters for the IGU. You got the its energy performances are related to the tightness of the unit. And so what we did was to identify three different series of glass. The first, sorry, just a second. Okay, no, this is still on the separation. So when we did the separation, that's how the residual looks like. That's another question that people were asking. So how clean is your glass out of it? So we do not have an automated cleaning of it yet. So what you have out of the machine is somehow the pictures that you can see here. Some cuts are quite nice, and probably you don't need to do nothing. Some others, you will need to do some blading out of it, some spatula usage. What we do right now, we do by hand, so we pass a spatula to have a nice cleaned edge. But you know, an automated line might have this part which will be automatically cleaned, so you will not have this problem. And so now I go to the part that I was mentioning before. Sorry for this hiccup that's due for not being the main speaker of that, I guess. And that is to validating the tightness of the IGU. So that's the edge, as you have seen it on the previous slide. What we do, we will have cleaned it with a spatula and then made aging tests. The aging tests are made in accordance to the EN 1279, and so that means you want to verify that it's tight versus climatic cyclic load, but you also want to verify that the sealant, once it's reapplied, it's compliant with some resistance in tensile, and the failure is always cohesive. So this is the test that we run at AGC. So we had three different series, and these are the series. One is the post-consumer panel. How this thing was done? Well, the way we see it is that a new IGU will not be solely done of post-consumer glass because you probably need an up-to-date coating there. So a new remanufactured IGU will be made of a new coated glass and an old post-consumer glass. So if you imagine our post-consumer glass is normally a rectangle, which we will have to recut. You want to optimize your recutting, so imagine you will shrink a big rectangle into a smaller. Instead of doing 4 cuts, we said, let's try to keep the edges and see if this performs. So the first series with the reused paint is made with one panel, which is post-consumer, and on 2 sides is where formerly sealant was applied, and we reapplied the sealant right there. You know, this is also intuitive. If you have a piece of tape and you put it on the table and then you remove it, then the adhesion tends to get lost, right? So we really need to have this test. We could predict it. Maybe, Valerie, you know, you guys know better this, but we had to do a little bit like San Tommaso, put the hand on the right spot. So we did that. And then the other series we had was completely new paint, so to have a reference, a benchmark. And then the other, we just trimmed the edge. So it was still post-consumer glass, but in that case, the sealant was applied on an area where formerly there were no sealant, so we had no doubt about it. And then out of the tests, we could not spot any difference between the new and the post-consumer glass. So luckily, this seems that there's no reason to trim the edges for the way we see this. And so, in conclusion, so far this machine has proven its potential for disassembly IGU, and then it will enable us to move on and to give a new life to this glass. So it can be used for repair, for recycle, and for use, and then it will be also a serious reduction in terms of CO2 footprint, and you know, it could be also it could give us the possibility to do a bottom-up approach towards the legislation, because the legislation is a little bit like us. We have a lot of work to do if we want to enable this, and maybe the legislation is so busy in doing things. But if we prove some concept at the first hand from the bottom, then we can show as an example what can be done, and we hope that this will become widespread in the future. And I would like to conclude this call to thank the person who is behind this machine, which is Dr. Markus Scheusful, who could not be with us here today. As we speak, he parted ways with EGLA, but I would like to thank him for the motivation and curiosity with which he worked on this machine, and his contribution is essential, and I'm also sure that he will keep on orbiting into this project to get the right kicks that we need to bring this to the real point that we needed to enable the use of post-consumer glass. Thank you.